Hello, everyone, and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to join StreamYard to share what you've been working on with everybody, you can find a link to live broadcast chat over in our Discord at adafruit.it/Discord. But first, we're going to kick things off with my wonderful coworkers on the creative engineering team at Adafruit, starting with Erin St Blaine. Hello. How
Hello,
are you?
I'm fantastic. I am showing off my latest project today, which
Excellent.
is this lovely tree branch that's on my wall. I've got I just found it outside. They were trimming trees down by the river.
Nice.
And I put some lights on it so it glows.
Ooh.
I'm using Adafruit's little seed pixels, or pebble pixels they're called, because they're really a little flexible strand that you can make it bend and twist and go around. And I just use the staple gun to just attach them to the back of the branch. And it turned out really good. And I'm using the WLED app right here. So the way this works is I can choose different colors, and just, when I click on the app, it changes the colors on the tree. Cool. It's a really nice user interface, really easy to use. There's lots of different animation modes too. I can make them go chase or twinkle or what, there's a whole bunch of different options. And then I can save my favorites as a preset.
That's awesome.
This is running the Adafruit Sparkle Motion Board, which is hidden right back here below the bottom of the branch. And it was a really easy project to do. Doesn't require any coding, doesn't require any soldering, because the board has some screw terminals. So if you don't even have a soldering iron, this is a pretty easy project that will really level up the room.
Those are my favorite types.
Yeah, and I've got it right here by my bed, and so I get to, look at it at night. At night, it's really fantastic. I can't make it dark in here without skylights. But
I was seeing too in your guide photos, the shape of the branch kind of almost reminds me of a lightning strike too. So you also get kind of that silhouette going.
Yeah, and that's a great idea. Maybe I'll make some animations where it looks like lightning is coming down. That would be pretty cool. And I think that's possible to do in WLED. There's just a lot of options. So
yeah, there's so many. Yeah. Well, thank you so much, Erin. It's always awesome to see what magical things you're working on.
Yep, the tutorial is live. So if you're interested in making this or sharing it with a friend, then go for it.
Excellent. All right. Have a good evening.
Thanks.
All right. Now we're going to hear from Tim, also known as foamguy.
Hey, Liz. How are you? Doing pretty good. Thank you. So I have been working, as you know, on lots of drivers for these new breakouts that are coming out. And one of the things that we've been trying to do is write a bunch of tests. Lady Ada's been writing a suite of hardware tests for the Arduino driver, and I've been converting that to Circuit Python. And I haven't had always all the same hardware hooked up to be able to actually get the most out of all the tests. Some of them were using servos and different stuff, and I wasn't all hooked up for it. So I've been working on that this week. I built this whole little Connects rig. It's kind of just a basic little setup that has NeoPixels, so we can shine lights on it. We're testing out a light sensor in this case, light and proximity. So we've got NeoPixels for lights. I've got a servo back here that just has a little index card on it, so we can bring that in front for the proximity testing. All the wires can run out the bottom. There's lots of room for everything to be all wired up here. And then right now I have it hooked up to the Fruit Jam is what this one is. So we can run these tests. And I have this open here, which is just like a list of all of these different tests. And they all kind of test a different aspect of the hardware. So this one is doing the light sensing. It's going to make sure that it will blind it with these bright NeoPixels. And it's going to make sure that the readings for the light, the lux, and the white channel all actually go way up when the lights are on. So it's like validating that the driver is working correctly. And then the servo one, which I think is the funnest. I just got the servo hooked up yesterday. I 3D printed this little adapter that kind of shoves onto the stepper motor mount there. I keep calling it a servo accidentally. It is a stepper motor with the TMC 2209 is what's driving that there. But this one I think is kind of the coolest one in my opinion. So I have a bunch of these loaded up here, but we can do the proximity test. It will check the proximity with the card there, and then it'll run the servo to move the card out of the way, check the proximity again, and then move the card back in, and again validate that the data actually makes sense. So it will make sure that
really
the
cool.
Proximity when it's there is close, the proximity when it's gone is far, and all that stuff. So we have in this repo, there's like 12 of these different tests that test all these different components of the hardware, and then One thing that I'll mention real fast, and I could start showing it, but we don't have to let the whole thing run, is I've also done like a meta sort of next level up that runs a PyTest script that will go and collect all, in this case, 12 of these test scripts and run them back to back and get the results of all of them right away. And then you can kind of do them all, sort of walk away, fill up your coffee, that sort of thing, and come back to all the results. And then one of the really neat things about this is while we're writing all these tests, I'm also building out agent skills. So for tools like Claude Code and similar sort of agent style command line interfaces, we have markdown files, which are published on GitHub. So other people can use these as well. But we have skill markdown files that walk the agent through how to write these kinds of tests and how to run these kind of tests and get all of the results, and then even do some analysis on the results. So if some of the tests fail, it can go and read the code and decide, like, based on the output, why does it think it failed, and maybe even offer suggestions or try to fix the test, that sort of thing. And then if we have time, I'll show you one other set of tests that I've been working on, which is more mundane perhaps, but also a really cool thing that we're working on. So those tests from before, those are all kind of testing the functionality of the sensor. You know, is it getting readings that look sane based in different environmental conditions and that sort of stuff. But this other kind of test that I've been working on is actually more low level with the data on the I2C bus. So we have another series of tests that will go through and sort of read and write all of the configuration settings, all the properties that access configuration registers. It will read and write all of them. And they have this I2C debugging, which is super easy to turn on in both Arduino and Circuit Python, that will print the raw data that is being written and read on that I2C bus. So when you run it, you get this big list out of all this hex data that's going across the I2C bus. For a human, obviously, this doesn't make a lot of sense. If you have a data sheet, you could map it up, but it's kind of like gnarly
even
to
then
look at. Yeah, no, it's tough out there. And so I have written 2 versions of this. There's an Arduino run, an Arduino 1, which will compile and run on Arduino. So I have a Metro hooked up here that will do that. And I can actually, I don't know why we're just scrolling here. I can actually do this. And so you'll see it will flash the little programming lights there. It's actually compiling and running that script on the Metro. And then it will print all the stuff it gets and gets all these same things. And then we have a Circuit Python version, which essentially does the exact same thing. It's accessing all the same registers. And it also has a I2C debug thing. The format is like ever so slightly different, but it's basically the same concept where it's just printing all this raw data that's coming out. And so I have written another agent skill that is able to write these tests, and it will go through and test each of those different configuration registers. So this is just the first one, but there's like 10 or 12 of these as well. And similarly to the other one, we also have like sort of the next level PyTest script. So once you have all these things existing, you can also run a PyTest script that will go through the list of all 10 or 12, run them first on the Arduino device and then on CircuitPython device, and it will compare all those raw bytes in here and actually make sure that they match byte for byte. So we can confirm that the Arduino driver and the CircuitPython driver are reading and writing all of the exact same data on the I2C bus. So just a different way to validate that those drivers are behaving as expected.
That's great. I've had to do that before when doing the e-ink drivers, but I haven't previously with the I2C drivers. Like I haven't had to get into the step-by-step comparison. Were you finding that any of them were like off or? Yeah,
so this has, being able to write these tests has highlighted a few things for me. There were a couple of cases on some of the drivers that I worked on where there was just differences in the init. So like one of them would init under, like the Arduino driver would init under one config, you know, for like data rate or something, right? And then the CircuitPython would just use a slightly different one. And so it highlights that sort of thing. So we can easily find those and fix them to make the drivers in sync to behave the same. And then the other thing that I've found is sometimes like there was an issue where it was not resetting back to a known good state. So like if you ran a certain test, it would leave it in a state. And then if you ran another one, it would cause that one to fail because it wasn't expecting to read certain data out. So in that case, it wasn't really an issue with the driver, but this test did point it out, and I was able to go back and actually get all these tests to kind of force it into a reset, a default state right out of the gate, so that before it starts printing all of this debug stuff, it gets it into a known default state. That way the comparisons come up. So yeah, it's been super cool. It's pointed out a couple of different issues as I'm working on the drivers. And I also found one on the APDS 9999, which I did a couple of weeks back, that I need to circle back to. One of these tests actually highlighted that the interrupts were not working as expected the other day when I was first working on this. So got to circle back and figure out what's going on. But these tests, as I've been working on them, are highlighting that sort of issue to me. So it's really cool to be able to set this stuff up and even get it so far as like the agents can run it and see the output and suggest like what to do next, or just validate that the drivers are behaving correctly is really cool.
That's awesome. That's really great work. Thank you for working on this. And I also want to give a little shout out to the fact that you use connects. So many people just kind of do Lego. So I feel like it's very, very punk, very cool to actually be like, no, I'm going to use connects. Okay.
Yeah. I've got this big box of connects that makes like a Ferris wheel or something I've had since I was a kid, and I'm always busting it out every few years to just build something. So nice little base station to start from.
Definitely. And you are doing Deep Dive this Friday, right?
Yes, that's right. Yeah, Scott's out this week, so I will be there on Friday for Deep Dive. And for folks that don't know, I also am streaming on Tuesday mornings now. So very similar kind of content that you'll find whenever I'm on Deep Dive. You can also get Tuesday mornings now, 11 a.m. Eastern here on the Adafruit channel.
All right. Awesome. Looking forward to it. Thanks so much, Tim, for coming by.
Yep. We'll see you.
Have a good one. All right, now we're going to hear from some folks in the community, starting with our friend, Paul. Hey, Paul, how are you?
I'm good. Thanks for hosting.
Of course, yeah.
Wanted to stop by and share that I have a new Circuit Python show episode with Adafruit's own John Park that came out on Monday. He and I had a real fun conversation about how he got started hosting back in the day with Make Television, to hosting on Adafruit, and some behind-the-scenes stuff. At one point, he shares what one of his favorite things is about hosting, and that's when the projects he's working on break. And he has a chance to show that it happens to everyone. And then when he loves it when someone in the community will step up and speak up and say, hey, maybe you want to try this, or they're able to fix it that way. And it was just a really great conversation with JP.
It is a really great episode. I've also listened, so I hope everyone goes and listens to it. And I hope you'll put the link in the live chat so folks can go right after this.
I'll do that. Thanks.
All right. Thank you. Have a good one, Paul.
You too.
And now we're going to have Cooper play us out.
How's it going?
Good. How are you?
Pretty good. So I took a break a while back, being distracted by the whole fruit jam stuff, which is super fun. But I wanted to get right back into guitar pedal stuff, which I had done some work with a while ago. Excuse me, sorry, rearranging things. Anyway, so I was working a lot with the WM8960 codec, which actually I think y'all have. SparkFun shares that. Has a module for it, and it's using the voice bonnet as well. But I quickly found out that it had a really high noise floor, and it was kind of an issue, right? So I was really inspired by the chip in the Fruit Jam, which is the TLV 320. You should know, I think you worked on it a lot, right?
I just called it TLV 320.
Exactly. Well, this is one of its little brothers here, which is a codec, which is AIC 3204. I actually have this up on my Tindy store because I got a batch of them,
Oh, nice. Okay.
And it's basically a do-it-all kind of audio codec. It has headphone output, it has line level output, it has line level input, as well as microphone input, and a bunch of other settings. So recently I put this out, and it's available in Osh Lab, whatever. It's my first time using that, so we'll see how that goes. And I recently put some work into creating a library for it with a bunch of examples of how to get data in and out of it. Of course, you can just use I2S out. But I have a little demo here that's been going while we're talking. There we are. And this is actually taking just a standard microphone. I believe it's on Adafruit's site. So it's totally analog. But it's taking that input into that DAC, with a little Pico 2 over here running Circuit Python, and then drawing a volume graph of it over time, right, on the display here over I2C. So that's the start of what I'm working on, just doing tests and stuff like that. The end goal is something a little bit more like this, of course.
Hey, now.
Always pedals, right? And had to put Blinka on there. So I have a little, a little Pico with that chip, as well as some other chips to do power delivery and preamps and things like that.
Nice.
However, there's some hardware issues I'm working through right now, so I don't have a demo. So I apologize for that.
No, I mean, this is all great. That same this chip, the TLV with the AIC, Seed Studio also uses it, and they're like V2 of the bonnet, but it doesn't seem to be available for purchase anywhere in the States. So it's interesting to see it as that you have a breakout for it. Like, that's good to see.
I did design the library here so that it was using the register library and all that kind of stuff.
Nice.
So it is available on PyPy. So it should be, fully functional with Blinka. So if that voice bonnet comes out and someone's interested in talking with it over Blinka, that should work as well. Fingers crossed over here. That's all I got for you. And also I wanted to say I had listened to that podcast episode already as well. And I then watched, because they mentioned John Park, how he was on the Make television thing, which I wasn't aware of. And so I binged the entire series.
Oh, you did? Yeah, it's a good one.
It's really great, really great. Anyway, that's all I got for today. But,
all right. Well, great work, and look forward to seeing your progress with it.
Totally. Thank you for having me on, Liz.
Of course. Yeah. Have a good one. All right. That's going to do it for tonight's show and tell. What a fantastic round of guests. There is going to be no Ask an Engineer tonight, unfortunately, but there is John Park's workshop tomorrow at the usual time, 4 p.m. Eastern. As we said, Tim's going to be deep diving on Friday at 5 p.m. Eastern. And then, of course, next week begins the next round of wonderful shows. But until then, hope everyone has a good evening, and we'll see you next time. Bye.